So let's look at relational algebra. Now, I know that the moment that you mention algebra to students, suddenly the shutters come down and they start panicking like crazy. But in this context, the way that we'll use algebra is very much as a sort of teaching tool, so you can understand the basic kinds of operations that actually occur inside a database product that supports the relational model. Now, tables and relations are manipulated by these kind of base level operations which we can express in relational algebra. And there are some basic ones and there are some advanced ones. And what it really boils down to is you can visualize this as being a table that's split into particular rows or particular columns. We're merging tables together, and those are the kind of base level operations that we perform on a table when we're actually asking questions of the table, when we're asking sort of queries of the table. We want a response back. Now there are 5 basic operations in relational algebra, and you can see they're here: selection, projection, Cartesian product, union and set difference. And there's a notation that's accompanying those. So we use a small sigma for selection and a small pi for projection. And then you can see we use a cross for Cartesian product. It looks very similar to multiplication. We've got union and set difference. There are 3 other operations that you can actually build out of those, which are join, intersection and division. And I'll mention those in passing at some point. So I'm going to start off by looking at projection. That's that little pi symbol. And what projection enables us to do is to actually choose particular columns. So let's imagine that you've got a relation, and what you would like is you would like to extract certain columns from that relation. We're going to use this projection operation over that table, over that relation, to actually pull those particular columns out. Now here's the formal definition of projection, and here's an example of the way that we would actually use it in practice. I think it's easier if we actually just do this with a quick demonstration. So here's my emp table, and the columns that we've particularly got here these are the attributes: emp number, ename, job, manager, hire date, sal, com and department number. So let's imagine that we wanted to actually extract a subset of this relation, particular columns. Now, because we're looking at particular columns, we're going to be using projection. Obviously, that's the way this example has been set up. And what's it actually asking us for here? Well, it says produce a list of salaries for all staff showing only the emp number, ename, job and salary. So the particular columns that we're interested in are these. So we just want those 4 columns. And if we want particular columns, then immediately we go, okay, that's the projection operation. That's what projection does for us. Now, to write that actually down in relational algebra, we use this notation, and it's quite straightforward really. First thing we would do is we put the named relation inside the brackets. And in this instance, the named relation, what is the name of the table? Well, that's the emp table. So we just write emp into there. Now you can see we put emp in brackets. This notation is suggesting that we're applying the projection operation onto the emp table. So we put a pi right at the front. We're saying we're going to use this projection operation, and what we're going to do is we're going to extract certain columns out of the emp table. All we do is we write down the particular columns we're interested in, the names of those columns, in other words, the attribute names of those columns, separated by a comma. So we're particularly looking for, if you look at the question at the top, the query at the top, we're looking for emp number, ename, job and salary. So all we have to do is pop those in there, separated by comma. And that's what this is actually saying. It's saying project, give me 4 particular columns, emp number, ename, job and sal, from the emp table. So if we could run this, let's imagine that we could run this against the database, what it would actually do is it would give us these particular 4 columns. Now, we can't actually type those relational algebra operations into the keyboard. So what databases do is they offer us a way of actually having a query language, and that query language is actually translated into those relational algebra operations for us, and those operations are then run against the table. The most popular database programming language that's out there is SQL, Structured Query Language, and that is the one that is typically available for almost all databases. It is if they are databases that support a relational model, so things like Oracle, MySQL, MSQL, PostgreSQL, all those things are Access. All of these database products support SQL, which is nice because it means if you equip yourself with the skills to know SQL, you know that's very much a transferable skill. There'll be minor tweaks required as you move from product to product, but SQL is something which is universally supported with databases that do support the database relational model. So I'll talk about that in the next video.